Good evening. I am Ajit Kumar Anand. I am going to explain about logarithmic function. Okay. Shortly, this is known as log function. Okay. This is known as log function. Log log. And another symbol for log is ln, which is a special type of log. I will discuss this later. Okay. This log. Okay. This log is actually a function. What actually function does? Every function you give some input to it, it does some operation on it, after that it gives an output you. Okay. Similarly, log is also a function you give to input it. If you give input to it, it will give output to you. Okay. So what I will come on definition later, but firstly I will show you what actually log does. Okay. So suppose in log is actually two input function. Okay, one input is written on top of this log here, top of this log, and one on bottom of this log. Okay, so this top, suppose I am writing here a and b in b here. Okay, so this a is called argument of log, and this b is called base of log. Okay, so this is read as log a with base b. Okay, so what actually it does? Okay, I am taking some example to show firstly that what it does. Okay, so I am taking just 4 on place of argument and 2 on place of 2. Okay, so log calculate how much power you will give on this 2, so you will get 4, right? So clearly you can see, if you will take if you will give power 2 on this 2, okay, you will get 4, so value of this log will be 2. Similarly, if you have 8 here and 2 on base, okay, so you have to calculate how much power this log will calculate, how much power will give to 2, so we will get 8. So how much power of 2 will be equal to 8? Obviously it will be 3, so value of this log is 3. Okay, similarly here log 27 and in base 3. Okay, so it will be also, how much power of 3 will be 27? Obviously 3, so 3 to the power 3 is equal to 27. That's why value of this log is 3, right? Now I will come on definition. Before that, just see log here minus 27, okay, here minus 3. Till now you have held what log does, so you can say easily that you will do operation, you will do power of 3 on this minus 3, so you will get minus 23. So logically there should be a value of minus 3. Okay, but this is not possible. Okay, sorry, not minus 3, it will be 3. Okay, but this case is not possible because we have taken negative as argument and negative as base. So it is a case of domain. We will discuss later in domain case that why we can't take negative argument or negative base. Okay, now coming to definition. What is the definition of log? So till now you can feel that what log is doing. So with help of this definition example, you can now make a definition that any number n is called the logarithmic value of x to the base a, such that a to the power n equal to x. Okay, what I have said, any number n is called the logarithmic value of x to the base a, such that x is equal to a to the power, and this is the definition of log. Okay, now I will come on domain of this function. Okay, so see, I were explaining that you cannot take negative argument or negative base. Suppose here it is x and here y, so x should be always greater than 0 and y should be always greater than 0, and another important case, y should not be equal to 1. Okay, so if you on place of x you have if you have negative number, you can say this log is not defined. Similarly, if y is negative, you can say this log is not defined. And yes, if y equal to 1, obviously then also you will say this log is not defined. How? Why? First easy one. Why we can't take y equal to 1? Suppose we have on place of base we have 1. You will put any number here. Suppose 2 or 3 or 5 or 7 or -2 or any number. -2 you cannot put because, okay, we will discuss later. Because you know, if you are taking value of this log as n, so 1 to the power n should be 2. So is there any number possible that one you will do power on 1 and it will give you 2, or any number? Because 1 to the power n is always 1. So doesn't matter how much power you are doing, it won't give another value. That's why you can say you can fill any number, any power on this 1 cannot give you 2 or any another number. That's why there is no meaning of this log. That's why this log is not defined. Okay. Similarly, why we cannot take x as negative? Okay, why we cannot take x as negative? Actually, log is inverse function of. Actually, log is inverse of exponential function. Okay, so you know, suppose we have a to the power n is equal to x. Okay, you know, this is in case of here it is y. Okay, a to the power y equal to x. Okay, you can take any number, but overall value of okay, so you cannot take a arbitrary, because if you will take negative here, in case in exponential case, you know, you cannot take base of any exponential as negative. That's why, okay, here I am taking suppose y to the power a equal to x. Okay, so because in inverse we are taking this base is as log base of log also, output of this exponential function is now input of our log, and this value this power value will give the value of log. Okay, so you can say y to the power a, it will be always greater than 0 now, because exponential function is always positive, and we are taking log as inverse of, because log is inverse of exponential function. That's why output cannot be negative. So now this x is working as input of this log. So obviously this x should be always greater than 0, and this y should be also greater than 0, because if you will take negative of -2, it will give you very problematic to calculate. Suppose in the case of radical power -1 by 2, it is actually possible, but if you will take -2 to the power 1 by 2, it won't be valuable case on in real valued function. That's why you cannot take negative. Okay, now clearly why I have discussed why can x should be greater than 0, y should be greater than 0, and y should be not equal to 1. Okay, now coming to some property. Okay, I will just explain one basic property and two important property. Rest I will just write. Okay, one basic property is log a with base b plus log c with base b. It is actually log a into c with base b. Okay, you can prove it easily. You just take it as x and this as y. From log definition of logs, you can write x equal to b to the power x. From here, x not x, you can write a equal to b to the power x and c equal to b to the power y, right? So from RHS you can see, you can write log on place of a, you can write b to the power x, and on place of c you can write b to the power y. and here it was b. Okay, so log b, and you know if base is same, power of exponential is added, so b to the power x plus y. So it is clearly written now. It is clearly written how much power you will do on b, so you will get b to the power x plus y. Obviously it will be x plus y now. How much power you will do on b, so you will get b to the power x plus y. Obviously it is x plus y. So x plus y, what was our this x plus y was our LHS. So yep, so it's proved now. Similarly, there are many basic property. I will just write them, and I will prove another two important property. Similarly, log a with base b minus log c with base b, it is actually log a upon c with base b. Okay, another property, if okay, one is very interesting property, if base and argument both are same, then obviously from definition of log, what should be the value what power you will do on a, so you will get a, obviously 1. So you can say if base and argument is same, that log will give you 1. Okay, right. Okay, so in interesting result, log 1 doesn't matter what is the value of x. Obviously x should be positive and it should not be equal to 1. Okay, so what should be the value of this if your x is greater than 0? Okay, because for x negative it is not defined, right? That's why. Suppose now what should be the value of this log? You know, 1 should be, suppose it is n, so x to the power n equal to 1, and you know if you will put n equal to 0, it will be x to the power 0, and any number, any positive number to the power 0, it will be obviously 1. Okay, so value of n x to the power 0 will be 1, so value of n is 0. So you can say log 1 is 0, doesn't matter what is base, but it should be positive base, obviously. Okay, another important property, it was also important property, another basic property I am taking, just log a to the power n and base b. Here you can write n into log a with base b. Okay, this is a basic, very basic property. And one is log a with base b into log b with base c. It will be equal to log a and base c. Okay, with help of this basic property, I will explain two very important property, okay, of log. First, I am taking very important property. It is if you have a to the power log b with c, okay, or you can take c with base b. You can write it like c to the power log b and in argument a. Okay, just okay. So here where there is one basic property is if we have log c with base b into log b with base c, it will be equal to, here you can write it as log this b and this b is same, so you can write c log c, so argument and base is same, so it will be 1. Okay, so the value of this log should be 1, so you can write log c with base b equal to 1 upon log b with base c. This is also very basic property. Okay, I will use this in proving this. Okay, that's why I have written it. Okay. Now I am taking LHS. From LHS, here you can write a to the power log c and in base b. So I am introducing here a into log a with base b. You can write like this because this a and this will be cancelled out. We will have only log c with base b. Okay, now you know if from a to the power, if you have a to the power x into y, you can write a to the power x whole to the power y. Okay, so similarly here you can write a to the power log c with base a to the power log a with base b. Okay, this value of this will be c. Okay, this is also a property, a to the power log c with base a is equal to c. Okay, so from here you can write c, and it will be c to the power log a with base b. This is your RHS. Okay, so it is very important. Okay, another very interesting result you will see is okay, I will just explain it, that a to the power root under log b with base a, it will be equal to b to the power root under log a with base b. Here you can prove it here also. Here you can take e to the power root under log b with base a, and you can multiply 1 because no effect of multiplying 1 in any question. Okay, so on place of 1 you can write log b with base a into log a with base b, because multiplication of this is 1, right? Product of this will be 1 now. So you can write now. Here you can see under root this and these two factor we have, so we can take one outside of root. So we have a to the power log b with base a root under log a with base b. Okay, similarly we can write this as power to the power, so it will be a to the power log b with base a. Okay, to the power root under log a with base b. Okay, now this and this will be cancelled out. You can say cancel out. We will have only b, and it will be b to the power root under log a with base b. Okay, this we have in right hand side. Okay, so this is also a very important property. We can use this property to get to simplify question. Okay, thank you.